last week we looked at the Ka, or the acid ionization constant. And the acid ionization constant would have something like hydrogen fluoride plus water creates hydronium and the fluoride ion. And so your Ka expression for this is the concentration of hydronium times fluoride over hydrogen fluoride at equilibrium. And so the Ka values are listed in your data booklet, and those Ka values are able to be used to find the concentration of hydronium in weak acids. They'll be the square root of the Ka times the concentration of the acid if the the concentration of the acid divided by the Ka is greater than or equal to 1,000. So we did that in the last video, and we're going to do a very similar thing now, but instead we're going to deal with the Kb. So if we had fluoride ion and water will react to make hydroxide ion and the hydrogen fluoride ion. And this is our Kb. So the hydroxide ion concentration times the hydrogen fluoride concentration divided by the fluoride ion concentration is our Kb value. Now, the Kb value is not listed in the data booklet. So if we look at our data booklet and we look at hydrogen fluoride, the Ka is for this value. The basic form of the conjugate base for hydrogen fluoride is fluoride ion. And the Kb can be calculated. But the Kb is going to be for the entity that's listed in as the conjugate base. And the Kb almost should have its own column, right? Like if that's Ka and the Ka is for the acid form, the Kb should be for the base form. And that value would go here. They don't list it because it can be calculated, because Ka times Kb equals Kw. So the Kb that applies here equals Kw divided by the Ka for the conjugate acid. So if I had Kw divided by the Ka for that, we could calculate the Kb. So the Kb for fluoride ion is going to be 1.0 times 10 to the negative 14 divided by the Ka for fluoride's conjugate acid. So it's going to be divided by 6.3 times 10 to the negative 4. That's the Kb for our conjugate base. So I'll put that into the calculator and see what we come up with. So my Kb for fluoride is going to be 1.6 times 10 to the negative 11. And that value belongs here. And again, if I looked at this, the Ka that is listed here applies to this column. And the base, the conjugate base, we can calculate any of those values using Kw divided by the Ka for the conjugate acid. The reason that I kind of keep going back to that is going to be more apparent in a moment, but it is really, really important to know that if this is the acid form and this is its Ka, if I want to find the Kb, it would go here, and I am using this Ka to calculate it, so that the Kb equals Kw divided by the Ka, and that Ka is this value because it's for this entity. So, going back to our equilibrium notes, the KB here we determined was 1.6 times 10 to the negative 11. And again, if the concentration of base divided by KB is greater than or equal to 1,000, then the hydroxide ion concentration will equal the square root of the KB times the concentration of the base. And so we're going to be able to use that same kind of assumption for these calculations. But now I'm not given the KB, I need to determine the KB. So we will try doing a question like that. We'll do the first question here where it says codeine, an ingredient in migraine pills, has a KB of this. Calculate the pH of a 0.02 mole per liter codeine solution. So they're asking for the pH, so I'm going to need the hydronium concentration. But using the KB, all I can calculate is the concentration of hydroxides. So I'm going to do my check. I have 0.020 mole per liter. I'm going to divide it by the KB, which is 1.73 times 10 to the negative, I think it says 6. And I want to make sure that this is going to be a number that is greater than 1,000. And this is, when I calculate this, it gives me 11,560. And so the assumption works. So the concentration of hydroxide ions can be calculated using the square root of the KB times the concentration of base. And I want to make sure I'm sticking with the actual numbers that they're giving me, right? So that sounds a little dumb when I say it out loud, but since they've given me the KB and they've given me the concentration of the base, I can't just go backwards and start using a Ka directly. I want to use the KB to get the hydroxides and then figure out the pH from there. So here I've got the KB, and I'm going to multiply it by 0.020 mole per liter. And I'm going to take that square root to give me the hydroxide ion concentration. Sorry. So what I get is a hydroxide ion concentration of 1.84 times 10 to the negative 4 mole per liter. So from that hydroxide ion concentration, I have a few different moves. My Kw equals the concentration of hydronium times hydroxide. So I could find the concentration of hydronium, taking 10 to the negative 14 divided by the hydroxide ion concentration, and then take the pH equals the negative log of the concentration of hydroniums. Or I could take the concentration of hydroxides and find the pOH equals the negative log of the concentration of hydroxides. And then pH plus pOH equals 14. So my pH would equal 14 minus the pOH, and I should come out with the same answer. So we kind of get like a diverting, two ways to get to the same answer, but it all starts using this kind of a calculation. I'm going to give you a chance to try doing these questions, and I might make a video for these specific questions because they can start to get a little bit tricky. People can get a little lost in them.